Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This lesson is part 2 in a series of 3 videos on vector functions. It is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. It is recommended to view part 1 on vector functions prior to watching this video. In this video, we will discuss motion along a curve, the unit tangent vector, and the principal unit normal vector. If the vector r equals r of t represents the position vector of a particle at time t, then the following equations hold. Position r of t equals x of ti plus y of tj plus z of tk. Velocity, or v of t, equals the first derivative of r of t, or dx dti plus dy dtj plus dz dtk. Acceleration, or a of t, equals the second derivative of r of t, or the second derivative of dx dti, plus the second derivative of dy dtj, plus the second derivative of dz dtk. Speed, being the scalar component of the velocity vector, equals the magnitude of the velocity, or the magnitude of the first derivative of r of t, which equals the square root of dx dt squared plus dy dt squared plus dz dt squared. As an example, find the velocity, acceleration, and speed of a particle at a given point whose motion in space follows the vector r of t equals sine ti plus cosine tj plus sine 2tk at the point pi over 2. Velocity, or v of t, is the first derivative of r of t, which equals cosine ti minus sine tj plus 2 cosine 2tk. Acceleration is the derivative of the velocity vector. Therefore, acceleration equals negative sine ti minus cosine tj minus 4 sine 2tk. We next take these equations at the point pi over 2. V of pi over 2 equals cosine pi over 2 I minus sine pi over 2j plus 2 cosine pi k. Cosine pi over 2 equals 0, sine pi over 2 equals 1, and cosine pi equals negative 1. Therefore, the velocity vector is negative j minus 2k. Acceleration at pi over 2 equals negative sine pi over 2i minus cosine pi over 2j minus 4 times sine pi k. Again, sine pi over 2 equals 1, cosine pi over 2 equals 0, and sine pi equals 0. Therefore, the acceleration vector at pi over 2 equals negative I. Speed equals the magnitude of the velocity vector, or the magnitude of the first derivative of r of t, or the square root of dx dt squared plus dy dt squared plus dz dt squared equals the square root of negative 1 squared plus negative 2 squared, which equals the square root of 5. Let C denote a curve traced out by a vector function r equals r of t that is continuous on A is less than or equal to t is less than or equal to b. If the derivative r prime of t exists and is continuous on the interval AB, and if r prime of t is never the zero vector on AB, then C is called a smooth curve. For a smooth curve C traced out by the vector function r equals r of t, for A is less than or equal to t is less than or equal to b, the unit tangent vector t of t to C at t is t of t equals r prime of t over the magnitude of r prime of t. The unit tangent vector is used to analyze the geometry of a curve. For example, find the unit tangent vector for the following vector function. R of t equals e to the ti plus e to the negative tj at t equals 0. Starting with the definition of the unit tangent vector, t of t equals r prime of t over the magnitude of r prime of t. Next, we establish r prime of t equals e to the ti minus e to the negative tj. The magnitude of r prime of t is then the square root of e to the t squared plus e to the negative t squared, which equals the square root of e to the 2t plus e to the negative 2t. Combining the two, we can now solve for t of 0, which is e to the 0 I minus e to the 0 j over the square root of e to the 0 plus e to the 0. Since e to the 0 equals 1, this simplifies to I over the square root of 2 minus j over the square root of 2. Rationalize the denominator to get the final answer, the square root of 2 over 2i minus the square root of 2 over 2j. For a smooth curve C traced out by a vector function r equals r of t, for a is less than or equal to t is less than or equal to b, that is twice differentiable for a is less than t is less than b, the principal unit normal vector n of t of C at t is n of t equals t prime of t over the magnitude of t prime of t, provided t prime of t is not the zero vector. For example, find the principal unit normal vector for the vector function r of t equals e to the ti plus e to the negative tj at t equals 0. The principal unit normal vector n of t equals t prime of t over the magnitude of t prime of t. T of t was previously calculated as e to the ti minus e to the negative tj over the square root of e to the 2t plus e to the negative 2t. As a review of the quotient rule, let's set the numerator of our function to be f of t and the denominator g of t. The quotient rule then states that the derivative of the function will be f prime of t times g of t minus f of t times g prime of t all over g of t squared. F prime of t is e to the ti plus e to the negative tj. G prime of t will be 1/2 times the quantity of e to the 2t plus e to the negative 2t to the negative 1/2 power times the quantity of 2e to the 2t minus 2e to the negative 2t. The 1/2 can cancel with the 2's in the last term, leaving a more simplified form. We then piece these terms together. Simplification can start with multiplying both numerator and denominator by the square root of e to the 2t plus e to the negative 2t. In the numerator, distributing this to the first term cancels the square root, leaving the quantity of e to the ti plus e to the negative tj times the quantity of e to the 2t plus e to the negative 2t. In the second term, it cancels with the quantity of e to the 2t plus e to the negative 2t to the negative 1/2 power to get the quantity of e to the ti minus e to the negative tj times the quantity of e to the 2t minus e to the negative 2t. In the denominator, the terms multiply to get e to the 2t plus e to the negative 2t to the power of 3 over 2. Distribute our two sets of binomials in the numerator to get e to the 3ti plus e to the negative ti plus e to the tj plus e to the negative 3tj minus e to the 3ti plus e to the negative ti plus e to the tj minus e to the negative 3tj. E to the 3ti minus e to the 3ti cancels. Also, e to the negative 3tj minus e to the negative 3tj also cancels. E to the negative ti plus e to the negative ti equals 2e to the negative ti. E to the tj plus e to the tj equals 2e to the tj. This is over the quantity of e to the 2t plus e to the negative 2t to the power of 3 over 2. Next, we need to calculate the magnitude of t prime of t. We'll simplify this by splitting the numerator. The magnitude is then the square root of the square of the I term added to the square of the j term. Simplify by distributing the squares to get the square root of 4e to the 2t plus 4e to the negative 2t over the quantity of e to the 2t plus e to the negative 2t cubed. Factor the 4 out of the numerator, then the rest of the numerator can cancel with the denominator. Take the square root to get 2 over e to the 2t plus e to the negative 2t. N of t equals our original t prime over t over the newly calculated magnitude of t prime over t. The 2's in the compound numerator cancel, and the compound denominator cancels to get the square root of e to the 2t plus e to the negative 2t. Next, we solve for n of 0. Since e to the 0 equals 1, we get I plus j over the square root of 2. We then rationalize the denominator to get our final answer, the square root of 2 over 2i plus the square root of 2 over 2j. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.